Welcome to the Data Hall YouTube channel. In this video, we are going to understand the for each loop in detail. So previously we have covered the basics of loop in Stata. Then we discussed the for values loop in detail, and now we are going to further discuss the for each loop extensively. Remember, the for each loop is more powerful and they have more options as compared to for values loop. So let's just start with the syntax of for value loop. So we type help, for each loop. So we type help for each and we get this help file. So we write the command name, which is for each, then the variable name, then we have these curly brackets. And if you are familiar with the syntax of Stata, I have a video on this. I would give the link in the description, which would give you an idea how to read the syntax in Stata. So this curly bracket means that anything within this curly bracket is optional, and this line means that we have to use one of these things. Either we would use in or we would use off. So we start with the command name, then any variable, then we would either use in or off. List type is optional. Then we have a list. Then within the curly brackets we write our command. So we have different types of this for each loops. We can use it for list, local, for any variable list, num list or new list. So let's start with the simple idea. So let's just say we have names of different individuals and we want to display the name of each individual. For that we would use for each loop. We write the for each loop, then variable name, it can be anything, it can just be an I, right? Then the word in, then within inverted commas we give each of the string that we want to repeat. So what do we want? We can have any command, but for simplicity's sake we are using display command, which will display each of these names one by one in the Stata display window. So we display the variable name. So in first instance it would display John, in second instance it would display Ali, and in the third it would display Shah. So let me run this command. Now you'd notice it first displayed John, then Ali, then Shah. So this is the simple idea. Let me go back to this help of for each loop, and this specifically is the syntax that we just used. We used the for each, then the name of the variable in, and we gave any list within the inverted commas. So each name in the list should be separated using inverted commas. So let me use other options of for each loops, or other types of for each loop. So in this simple example, although we got the idea, but it isn't practically what we would normally use for each loop for. Let's just say we want to run regression, and here you would see that we have different variables. We have data for different stocks, and we have some independent variables and a dependent variable. We have data for different stocks for different years. So what we want to do is we want to regress y on x1, then separately, then in second regression we want to run y on x2 individually, then again in third regression we want to run y on x3. So what you can do is you can type different commands, regress y on x1, then we can type regress y on x2, and then we can type regress y on x3. But this can also be done using a loop. Now in this case because we have lesser number of variables, it might sound easy to use the regress command rather than the for each loop command. But let's just say we have different variables, and within these variables we have different subgroups, or we have different years for which we wanted to run the regression. In that case, doing these regressions manually would be a time-consuming task. So we do it using a for each loop. We write the for each loop, then name, it is similar to this one, in, then each variable within the inverted commas, and we use the regress command instead of display command because this time we do not want to display the names, rather we want to regress them. Regress y, the dependent variable, then independent variable, or the name of this variable that we have defined, which would store the value of x1, x2 and x3. So if I execute this command, the same regression that had been done manually are executed. Similarly, what we can do is we can, instead of running just regression, we wanted to regress y on x1, x2 and 3 combined. But this time we just do not want the regression analysis, we also want the correlation and the descriptive statistics. So again, we use the for each loop similar to this one. Instead of the variable name, we input the command name. So we would first have the descriptive analysis, then we would have the correlation and then the regression. And so we have used this variable over here. So first it would assume the value of sum. So the command would be like this: sum y x1, x2, x3. Then it would assume the value of correlation. This would be the command name, and it would run the command, and so on and so forth, right? So let me run this this loop. Now you would see in first instance it displayed the descriptive statistics, then the correlation, and then the regression analysis. So we do not need to use different commands, but rather the same was done in the for each loop. Now we have this data for different symbols or different firms for different years. So if I tabulate the year, we would know that we have data for 2019 to 2021. And now what we want to do is we want to regress y on x1, x2 and x3, but for each year we want to do it separately. Panel data, rather we have an unbalanced panel data. What we want is we want Stata to automatically get the number of years for each symbol. So although in this case we know that there are 3 years, 2019, 20 and 21, but there might be instances where we would not know that what are the values of the variable within the variable, or there might be a lot of values within a variable. So what we want is we want Stata to get the unique values in a variable and then loop through all those values. So for example, we want Stata to store to get the year variable, then get all the values in the year variable and find the unique values and store them in a variable and loop through each value. So for example, we will use level of command, level of, then the variable name, which is year in this case, and it would store all the levels or all the values of this year variable into this new variable name. Then we would loop through this new variable name to the values of this new variable name. For each x in new variable, we want to regress if year is x. So it would first assume any value that is there. In this case it would assume 2019. In second instance it would assume 20, and in third it would assume 21. So let me execute it. So you would see this, we had this level of command and it assumed these 3 values because the year had 3 values. In your case it is not necessary that you would use it for years. You can use it, let's just say if there is a categorical variable and you want to run regression for each category separately, you can do it the same way. It is not necessary that you would use it for numerical variable. You can use it for a string variable. So then it is running the regression for separately, right? So for in 21 we only had 59 observations. In 20 we had 366 observation. But the issue is that we do not know which regression is for which specific year. So what we can do is we can add another command which would display the year. So now what it would do is it would first display the year, and then the regression, it would run the regression, right? So we now know that this specific table is for 2019 and so on and so forth. There is another type of for each loop which we can use specifically for variable list. Although we did the same in this case, but this isn't the right way of doing this regression analysis using variable name. The right way is to use var list. So we use the for each loop, then the variable that would assume the values of var list, then we give the list of the variables. The advantage of doing it like this is that okay, let me just run this regression. We would run y on each of this variable. It is similar to the one that we have applied over here, but in this case we are using a different type of for each loop. So it is running regression of y on x1, then on x2, and then on x3. The advantage of using var list is that we can use different shortcuts over here. For example, we can say assume the var list starting from x1 till x3. So if we again execute this command, it would have the same results. Or what we can use is we can use a wildcard which would assume with the value of all the x variables that we have in our data set, and again that would give us the same result. Lastly, let's just say we have different numbers, and although we can do this using for value loop, but let's do it using for each loop. We know that we have year 2019 to 21. So what we can do is regress y on all of these variables for each year separately, but using the num list rather than the level of command. So for each n, this is the new variable that will assume these values of num list starting from 2019 till 21. So it would run regression for each year separately. And this is what we saw it previously. We had 59 observations for 21, 366 for 20, and so on. So in next video, what I'm going to do is I'm going to give you a for each loop where we can get data from different files and combine that data into a single data file. If you haven't subscribed to this channel, please do subscribe it and hit the bell icon so that as soon as we upload a video, you are updated of that.